Yes, now I see us.
Oh yeah, let me.
Oh, I hear us. 25 people now. Hey guys, we got a fun show planned today. I'm gonna get at my questions because I'm gonna drop some names of people that actually took the time to write questions for us.
I'm just going to paste this URL into the chat of the other one.
Okay. Are you in the YouTube chat?
Yeah.
Okay. Oh wow, there's a huge lag. There's a big lag. Okay.
I've used that. You've got to not look at the at ourselves on the YouTube, because then you get confused. Yeah.
Okay, Justin Hernandez is asking, what is the subject today? This is an Ask Me Anything with Jonathan McDowell, which I'm pretty excited about. Some of you guys asked some questions ahead of time, so I have those ready to go. And I guess we should just start with the first one, and then I'll keep my eye on the chat, and that'll be good. You good to go?
I'm good to go.
Okay, well, you know what? Let's start with telling people just a quick little summary about who you are. I think a lot of people know who you are, but just for the people that don't know who you are, maybe let them know.
Who am I? Okay. Yeah, I'm Jonathan. I'm an astronomer at the Center for Astrophysics, Harvard and Smithsonian. And so for my day job, I hunt for black holes and I help operate the Chandra X-ray telescope in space. But I also have a big interest in the history of spaceflight, and that's come together as the new mega constellations that have been launched are having a huge potential impact on astronomy, on professional astronomy and amateur astronomy. And so I've been looking at what are the consequences going to be of Starlink and the other constellations as we go from thousands of operating satellites to tens of thousands to hundreds of thousands. And if you're an astronomer trying to take a picture of the sky, what's going to happen to your pictures?
Very, very good and relevant questions. So let's start with the first question. This one comes from Chris Mugalian. He says, can you ask him about the dark matter and the new ways we can measure it?
All right. Yes. So we're going straight into full astronomy. So dark matter. Well, we first realized there was a problem back in the 1930s. There was a totally crazy Swiss-American astronomer called Fritz Zwicky, quite a character, and he looked at the motions of galaxies. And he saw that they were orbiting around each other much faster than they should be, because if you just added up the number of stars and figured out how much gravity there ought to be. And so he deduced that there must be extra invisible matter that's now come to be called dark matter. It's a bit of a misnomer. That's causing extra gravity, that's making this extra motion. And in the 1970s, another astronomer called Vera Rubin showed that this dark matter was present in pretty much every galaxy, and that the galaxies themselves were spinning faster than they ought to be, that the orbits of the stars were faster because they were seeing extra gravity compared to, again, the number of visible stars in the galaxy. And so fast forward another 50 years, and we've really established that dark matter is ubiquitous in the universe, and there's a lot more of it than ordinary matter. And we still don't know what it is. It's super embarrassing. We've sort of mislaid 90% of the universe. And so one of the really nice ways that we've been able to detect dark matter lately is a technique called weak lensing. And weak lensing is if you have a cluster of galaxies that's got lots of dark matter in it, and behind it, there's some even more distant galaxies. The light from those galaxies gets bent by the gravity of the cluster, by the dark matter. And so it's sort of like a gravitational mirage. And the images behind get distorted and get amplified. And so by mapping that out, you can actually measure where the gravity is and therefore where the dark matter is. And so people have been doing that and really improving our understanding of how the dark matter is distributed, when it's in the same places as galaxies and when it's in some more widely spread. And at the same time, we have computer programs that kind of simulate the universe on your computer. And you start off with a big bang and you let the universe expand, and it naturally gets lumpy under gravity. And we now have a pretty good understanding of how you go from a really smooth big bang to a lumpy universe that congeals into galaxies. And you can make galaxies that look like the galaxies that we have in our universe, but only if you include dark matter. If you don't include the dark matter, the universe isn't quite clumpy enough to make galaxies that look like the ones we see.
Really?
And so it's all coming together, but and the evidence is, for a number of reasons, we think that dark matter is made up of elementary particles that are some kind of elementary particle that we just don't know about yet. It hasn't shown up yet in the big accelerators like the Large Hadron Collider. And so, there's this big tunnel under Switzerland, right, which accelerates protons and smashes them into one another really hard and makes kind of all kinds of particles. And the hope is that eventually we'll find one of the particles that makes up the dark matter, but we're not there yet. And so it's still, almost 100 years after its discovery, still a big mystery exactly what the dark matter is, but we're boxing it in. We're kind of, it's sort of like the cop shows where you have the wall of suspects. The wall is, the suspects are being narrowed down, and we know we have a pretty good profile of the culprit, but we just haven't caught them yet.
Okay. Wow, that is a lot of information. I just learned a lot right there. Before I forget, I feel like a lot of people have asked this question, and I know a lot of people follow me for Starlink. So let's get right to it. Some people say that, could the negative effects of the low Earth orbit satellite constellations be mitigated by, putting telescopes on the Starlink satellites? And one discussion that we had, you said that's not really feasible for a lot of reasons. Why?
Right. Well, the fundamental reason is, so almost every professional telescope on Earth is different, right? Astronomy isn't just, we take a picture of the sky with the biggest telescope we have. It's we take wide field views, narrow field views. We take optical fiber spectroscopy, where we take the light down an optical fiber and split it up into its different colors. We have a whole different, hundreds of different kinds of instrument and camera, and different sorts of optics on the front end, on the telescope. And so if you want to replicate all of that in space, even if the launch is totally free, right, you'd be talking not billions, probably trillions to be able to automate that. Even automating one space telescope is a lot of work, and it's not just like an Earth observing satellite that you can roll off a production line. So the effort involved and the cost involved and the time involved, it's just not practical at the moment. Now, I think we're going to be forced to it, 50, 100 years from now. But for the next 20 years, it's just not a solution.
So we've talked about some of the negative impacts of Starlink quite a bit. And Justin Hernandez asks right now, question for Jonathan, how consequential is it if astronomy is negatively affected due to mega constellations like Starlink? It's not just Starlink, Kuiper's on the way, OneWeb. So what kind of impact are we really looking at? Because I know you're concerned.
It's why do we care if astronomers can't do astronomy? Is that the question?
I guess. Sure.
Yeah. I mean, at some level, right, people have been looking at the sky for thousands of years. It's not just a professional thing. It's also, something that's important to a lot of cultures around the world. And so there's that. Can you, do you want to impact people's cultures without consulting them first? But let's talk about the professional astronomy. And, a lot of what we know, for example, about nuclear reactions and nuclear energy came out of studying stars and how stars make the elements with nuclear reactions. A lot of physics came out of looking at stars, and so that took 50 years maybe to percolate down to practical applications, but there's a long tradition of astronomical research having direct effects on people's lives just on a long time scale. On the more sort of direct and immediate side, one thing you might worry about is the search for asteroids and comets that might hit the Earth. And that's a search that would be particularly affected by these satellites, because a lot of them are near the sun, the ones that would threaten the Earth, and so you have to observe them early in the evening, where they're near the horizon and where the satellites are most prevalent.
Right.
And so that's a very practical thing. It would be unfortunate if, thanks to the constellations, we didn't spot the rock that was going to come and kill us, or the risk of one that, like, wiping out the dinosaurs one, right, isn't really that great, but the risk of one that could wipe out a city is actually not that small. And so I think it is this, what we call planetary defense, is an important role that astronomy plays.
Right. Here's a fun question from, is it Medotech? Will Elon Musk be able to colonize Mars in the time frame that he put, as I remember, 2024? I'd like to know if Jonathan thinks we can nip a Kessler Syndrome situation in the bud before it.
Right. So there's two separate questions sneaked in there. So,
I know.
Right. One is, 2024. Well, that was actually the Trump administration's goal for landing people on the moon as well. I don't believe either of that. I mean, in terms of Elon getting to Mars, we joke in the trade about Elon years, which are longer than everybody else's years.
Right.
Elon is good at a lot of things, but predicting schedules is not one of them. And so at least on the space side of his business, and so
So Mars not 2024, and probably not even the moon 2024.
Correct. I think maybe the moon with Artemis in the late 2020s, and Mars by Elon, or by Elon with government money maybe. I would believe early 2030s as a first visit, but a settlement,
That's a whole different story.
That's a whole different story, and that's a lot longer. And a self-sustaining, I mean, really the end game, right, is multiplanetary species. A multiplanetary species is not just, you can sustain a base on Mars as long as you keep sending sandwiches to them. Right, it's a base that can sustain itself without support from Earth, and that, I'm afraid, is centuries away.
Wow.
I mean, that doesn't mean we shouldn't do it, right? But it's replicating your whole civilization. It's not enough, right, to learn to grow potatoes on Mars, right, like on the Martian. You have to be able to build semiconductors on Mars and things like that, right? You have to replicate our whole industrial base there, and so I think that's 500 years off, potentially. Certainly a couple centuries off.
500 years. Oh my gosh. Okay, so here's another question. What is the average cost and wait time for a night of using a ground-based telescope versus the more well-known ones like the Keck in Hawaii? This is from the Blakester.
Right. So it actually varies, but say for a modest 1 or 2 meter telescope that's just getting some basic data, it's certainly the operating costs are probably tens of thousands of dollars a night. And then if you actually fly out to use it, right, that's another few $1,000s for the plane fare and the expenses. Nowadays, we more often do it remotely, but there's still staff, maintaining the instruments. And so these are expensive devices. I don't, you know, they're paid for out of the operating expenses of the observatory, not out of the individual astronomer's pocket, right? And then the wait time. So what we do is we have, for ground-based telescopes, we typically allocate them on a quarterly basis. And so I'm too late already for the full semester, but if I want to observe my favorite object next February, I'll have to put in the proposal probably September or October. And then that goes to a committee, which decides which of the proposals have the best science. And then they will allocate the time based on you know, which proposal. So it's sort of like a competition with a jury that decides, you know, who the best proposals are. And so I just, in fact, we do the same thing for like Hubble and for Chandra. We just got the results the other day for next year's Chandra Space Telescope time. I had asked for a couple days. I didn't get any. I'll have to try again next year. And so these things, there are typically 5 to 10 times oversubscription. That's to say, for every night of telescope time, there are 5 people wanting that night.
Wow.
And so you know, your chances of actually getting your proposal approved are not that great, even if it's a pretty good one. So telescope time is very competitive, even for the smaller ground-based telescopes. It's a bit easier, I think. You know, probably the oversubscription is maybe a factor of 2 for the smaller telescopes, but we do special things like we preferentially give time to graduate students who need the data for their thesis, things like that. So you get the training with a bit more, you know, probability than if you're just some, you know, established professional astronomer who wants to actually do, you know, get some great science, but you know, you've got to fight for it. And so yeah, it's pretty competitive.
It sounds competitive. Here's a question from Han Solo. If the universe is expanding, then the Earth's distance from the sun is increasing. How long until the Earth is inhabitable? And with that expansion, would Venus ever become habitable to human beings?
So this is a very common misunderstanding about the expansion of the universe. The universe is expanding, but only on huge scales. And so we're in a supercluster of galaxies. So the Earth is orbiting the sun, and the sun is part of the Milky Way galaxy. And the Milky Way galaxy and the Andromeda galaxy are dominating a thing called the local group of galaxies. And the local group of galaxies is only about 20 million light years away from the Virgo cluster of galaxies, which is a huge, it's like the local New York City, right? It's the big cluster of galaxies. And we are falling towards the Virgo cluster because we're part of the Virgo supercluster. That's about, you know, maybe 100 million light years across or something like that. And it's like a lump of stuff in the universe that's denser than the average. And that lump is moving away from other 100 million light year across lumps as the space between them expands. But within the lumps, it's not expanding. It's actually space is flat. And so you and I are not actually getting further from one another as a result of the expansion of the universe. The expansion of the universe is actually 0 on the scale of the solar system and even the galaxy. It's just happening on much bigger scales.
Okay. So what about the question of Venus? Is that not in the cards?
Okay. So then within our solar system, the orbits of Venus and the Earth around the sun, right, are not affected by the expansion of the universe. They are affected by, there are various effects that cause the orbits to change slightly over billions of years. But I'm not exact. I think the orbits are pretty stable for the next billion years or so. So The worry is that about 5 billion years from now, the sun will run out of fuel, of hydrogen fuel in its core. And the core will collapse a bit and the outer parts of the sun will expand, and it'll get really hot in the middle and start burning helium instead. When I say burning, I mean thermonuclear fusion burning.
Yeah.
And the sun will readjust itself so it has a really dense core and a really big thin atmosphere, which will be so big and so thin that the Earth will be inside it, and that will not be good for us.
But you said it's what, a couple billion years away?
About 5 billion years from now, so that will.
I might be around.
I mean, I would say, you know, plan on finding some other real estate around then, because the real estate values around here are just going to plummet.
Yes, yes. Okay, let's go to Charles Van Noland. I'd like to know if Jonathan thinks we can nip a Kessler Syndrome situation in the bud. I guess that was a different question.
Oh yeah, that was the second, right? Okay.
Yes.
So what's the Kessler Syndrome? The Kessler Syndrome is the worry that was raised in the 70s by an Air Force guy called Don Kessler, who noticed that if you do the math about all the satellites orbiting the Earth, if you have enough satellites, they're going to start hitting each other. And when one satellite hits another satellite, you get a whole bunch of debris that then goes on to hit other satellites, which cause more debris. And you can get a chain reaction that could turn our very expensive billions of dollars of space hardware in orbit into aluminum confetti, making a Saturn's ring around the Earth. And you know, people who saw Gravity saw a visualization of this that wasn't very realistic, because in the movie it happened, you know, in like 10 minutes, and realistically it takes decades to happen, but it will still happen. And so if you don't do something about clearing up your trash, you will make space unusable. Because it will just be full of all this shrapnel going around that will hit you if you try and go up in space, and so that would be bad. So we've been trying to reduce the rate of increase by doing things like removing rocket stages from orbit after they've delivered their cargoes, basically tidying up after yourself best you can. It's been somewhat effective, but not effective enough. And there's a bunch of old satellites and rocket stages from the Cold War that are still up there, that are causing a significant amount of risk. And then with these hundreds of thousands of proposed mega constellation satellites, yeah, as long as they're working, they can dodge each other, maybe, but it doesn't take much of a mistake to have an accident. And right now we're seeing just enormous numbers of close misses, and that luck is going to run out eventually.
Right. Especially.
And so I think we have to do two things. We have to have space garbage trucks that get rid of the bigger dead satellites, and we have to find a way to fund that and a way to operate that system. And we need tighter management of low Earth orbit, particularly. We need regulations that say you can only have so many satellites at each given height range. Right. You need a kind of air traffic control thing that says, right now what happens is, if my satellite and your satellite are going very close to each other tomorrow, we'll get an email from Space Force saying, one of you might want to move.
Yeah.
But what we really need is an international organization that could say, Eliana, move up 1 mile, Jonathan, move down 1 mile, rather than leaving it up to us, right, to kind of figure out what we're going to do, like air traffic control does, right? If two planes are getting close to each other, the air traffic controller will go, yeah, flight 418, you know, go up to flight level 30, and you know, they decide who goes where to avoid the collision, rather than saying to people, guys, you're about to hit each other, you might want to dodge. And so the problem with that, right, is that air traffic control can't be the Space Force.
Right.
Because if one of the satellites is Chinese and the Space Force call them up and go, you should do this, they're going to go, American military, we're not going to do what you say.
Right. So are we going to get that international cooperation?
I think eventually we will, but you know, it's a long way away, and that's the challenge. So that, you know, it's not the technical solution that's the problem, it's the bloody humans, right? that are always so difficult to work with. And that's,
and how often is that the case?
Yeah, right, exactly. Exactly.
Here's a question from Delta Uniform Tango Charlie Hotel Echo Sierra Sierra. He wants to know, how many anti-Starlink astronomer petitions has McDowell signed recently? So I think it's important for people to know that, like, you don't hate Starlink, right? You just,
no, it's cool. I just want it regulated and you know, modified to not ruin astronomy. And it's actually, Starlink is not the biggest problem. It's OneWeb and some of the other constellations, the Chinese GW constellation, that are even bigger threats.
Why?
Because they're in higher orbits. And so because they're in higher orbits, they move more slowly across the sky, and they're illuminated for longer, and they're illuminated later into the night.
Okay.
And so whereas the Starlink has agreed to put its satellites lower, and so it's a big problem for like the space traffic thing, but for astronomy, it's not as bad as the higher orbit ones. And no, I may have signed one of the petitions, but I'm not going out there and signing lots of petitions. I'm more, you know, talking with SpaceX and publishing papers assessing the issue and, you know, trying to work with other astronomers to assess what we can do.
Well, and SpaceX has taken some steps, right, to kind of mitigate the impact. How do you think they're doing?
I mean, they have added visors to the satellites to cut down on their reflectivity, and they've changed the way they orient the satellites a bit to cut down. And that has had some, I would say, mixed success. That it's won us about a magnitude in astronomical terms, like a factor of 2 or so in brightness in some of the time, but not all of the time. Like they're dark sometimes, but then if they're in certain parts of their orbit, they're as bright as ever. And so it's a start, but it's going to be an ongoing issue. And the thing is, it's, you know, that's great that SpaceX want to work with us, but without international regulation, there's nothing to stop some other country putting up some much worse constellation. Right, the technology is here now that you can. What Starlink demonstrated, unfortunately, is that it is technically feasible to put up a constellation that would be horribly bad for astronomy, right? Even though Starlink in the end isn't so bad, but just, you know, put a lot of Starlink type satellites without the visors in a 300-kilometer orbit, and boy, are you hosed. And so it's still a big concern, but we are grateful that SpaceX has engaged with us in a really positive way, I think. And, you know, we still have to keep the pressure on, because yes, they're doing it partly because they genuinely don't want to hurt astronomy, but they also don't want bad PR. And that's, you know, there's a bottom line issue. They still want to make profit. And so it's, however much I might love what SpaceX has done to the space industry overall, I believe that we have to be assertive about talking about the space environment and protecting the space environment and balancing the interests of the space economy with the interest that humanity has in preserving certain aspects of the space environment, like the night sky, but also like the level of space debris and things like that.
This question kind of adds on to that. Elon, this is from the Blakester as well. Elon has recently said he would go as far as painting the Starlink satellites solid black. Would this help anything, or would it cause black streaks instead of white?
Right. Well, the problem is that just makes them brighter in the infrared. I mean, the energy's got to come out somewhere. And actually, it makes it worse for Elon because I don't think he really means that, or at least I think his engineers will tell him he doesn't mean that, because it will cause big thermal problems for the communications payload. So they kind of tried this, right, with what they call DarkSat. They did a test satellite in 2020 called DarkSat, where they painted parts of it black, and what they determined was that made the interior of the satellite heat up too much, and so that wasn't great. So, but I think, you know, I take it in the spirit that he meant it, which is that he wants to make engineering fixes if he can.
Right.
And so I think that the engineering team that are working on this are very smart, and I've talked to several of them, and they will iterate in the SpaceX tradition, and hopefully they will come up with the next great idea. We'll see how good it is. So yeah.
There was another question on the community tab, and I can't pull it up right now for some reason, but are there any plans to replace Arecibo? Someone wanted to talk about that a little bit.
Yeah, that's a tough one. So Arecibo was this amazing radio telescope that was basically, you took this big crater and you lined it with metal and put a feed at the front. And many people will have seen it, for example, in the movie Contact, or in, was it Man with the Golden Gun? One of the James Bond movies that they were fighting on top of the hearse. It was a spectacular sight, and it did really important astronomy. And so, you know, it was getting old and it broke and crumbled. And so now the question is, do you build it again?
Yeah.
Or do you build something different? And there are people who are like really invested in Arecibo who want to just rebuild it. And then I think the leadership of the astronomical community is mostly saying, well, you know, there's a finite budget, right? What are we going to do with our money? It's not obvious that the thing you need most is another Arecibo, right? You've got to compete with other ideas that people have that may be even more innovative. And so I'm actually pretty skeptical that they will rebuild Arecibo.
Justin Hernandez commented again, let's start a space trash company, guys. Maybe it's cool just to talk about, you know, what are the efforts that you're seeing underway to, you know, remove space debris, and, you know, are you, you know, encouraged by the efforts that you're seeing, or any progress being made for companies starting up to do this?
Yeah, I mean, I think there's a lot of interesting things going on. It's a bit slow at the moment. I wish it would hurry up a bit. So what we've seen at the moment is a few companies that have formed and are testing out different ideas about how you might do this. And so there's a company called Astroscale that's based in Japan and England that has a satellite in orbit that's going to release a test satellite that has like a magnetic plate on it. And they're going to use a magnetic plate to kind of clunk and take it back out of orbit. Surrey Satellite in England tested some ideas. They had a harpoon that harpooned a target. They had a net that they threw around a free-flying satellite. The idea is you go fishing basically for the satellite. Yeah. And so the trick is, right, you've got a target piece of debris or a dead satellite that's tumbling, right? So you can't just go up and dock with it because it's got all this energy as it's rolling around. And so you have to sort of take out that energy first. And one way is to let it wrap a net around itself and then reel it in. And so there's a whole bunch of different ideas that are at the let's try this and see what works stage, rather than the let's build 100 of these and actually go do it. And so I think, you know, in a couple of years, we'll have enough data to kind of make that decision and start implementing something.
Charles Young had asked, are we alone out there, right? What is I think he's obviously alluding to UFOs or UAPs. What are your thoughts on all that? Right. I feel like it's been talked about a lot more recently with Pentagon report and you know, Galileo project now being announced. So
yes. Okay. So I mean, I think there are two questions about are we alone, right? There's, are we alone in the universe? And are we alone in our solar system? Right, locally, like, are they out there or are they already here?
Right.
I don't think they're already here. I mean, these UAP videos I find profoundly unconvincing, and I think they're just like electronic mistakes in the sensors and things like that, or insects getting too close to the camera or whatever. And I really think, right, that if aliens come to Earth, either, I mean, they're going to be so far advanced than us, right? Either we won't know they were here at all, right? We just won't see it. I mean, like, you know, it's like our own spy satellites, right, can see stuff from orbit without having to come down close. And if the aliens are going to be at least that good, so they won't be like, you know, dodging near some person out in the countryside and then running away. And so if the aliens come, either we won't see them at all, or it'll be like Independence Day. There'll be like a 10-mile diameter spaceship hanging over New York City, and we'll be going, uh-huh. And the captain of it will be, you know, appearing on the evening news and being interviewed. You know, it's they're not going to be subtle. Either they're going to be too subtle and we won't see them, or they're not going to be subtle at all. This halfway kind of trying to be subtle but failing, I don't buy it. And so the evidence would seem to be that advanced intelligent life is rare in the galaxy. We just don't see evidence of it yet. On the other hand, one of the things that's happened in the past few years is we now realize that almost every star you see in the sky has planets around it. A lot of them planets kind of the size of the Earth, but not as nice as the Earth, unfortunately. But even so, it's a big galaxy. There's got to be habitable planets out there. I think the chances, and this is something that we only learned in the past few years. We always wondered, but now we know for sure, right, that planets are common in the galaxy. And so bacteria level life on other planets, I'm sure exists in the galaxy. I think the statistics suggest that it's hard to see how that could not be true. And I think the task of the next generation is to hunt for and find evidence for that life. But if you look at the time scales for life evolving and for the galaxy evolving, if you've got aliens, right, the chance that they're at the same level of development as us is tiny. They're either going to be 100 billion years behind us, right? And so, you know, they're still ants, right? Or they're going to be 100 million years ahead of us, right? I mean, it's just like, if you go outside right now and talk to the first person you meet, right? They're probably not going to be precisely the same age as you down to like being born the same hour, right? They're probably going to be, if you're lucky, you might meet someone who's like, you know, within a year or two of your age. And the equivalent in galaxy terms is within 100 million years or so of your age, right? Because the galaxy lasts a long time. And so the idea that you're going to meet Klingons, right, isn't realistic. You're going to meet ants or gods, right? That roughly speaking, right? And so Independence Day is much closer than Star Trek in that sense, in terms of what you might expect with a spacefaring alien civilization. And so they'd be pretty obvious. And so the fact that we don't see them around implies to me that probably there's very few of them in the galaxy at the moment. Maybe civilizations don't last very long. We know of one, right? Us. How long do we think our civilization is going to last? Well, it ain't looking too great right now. And so, you know, and so maybe civilizations tend not to last long. Maybe intelligence isn't actually an evolutionarily adaptive thing, and it doesn't tend to last very long, right? And so we just don't know. I think that the chance that there are intelligences, you know, in other galaxies, that's just because of the numbers involved, it's got to be a good chance.
Right.
But ones that are close enough that we can have a conversation with them, which means, within 100 light years or so, we may not be that lucky, and that's very sad, but we've got to take the universe as we find it.
What do you think of Oumuamua?
Yes, Oumuamua, or however you
Hard
pronounce
to
it.
say. Oumuamua. Yeah.
Yeah.
Actually.
Oumuamua is an iceberg, a fluffy iceberg that entered our solar system, I don't know, maybe 100 years ago, but it was detected a couple years ago, just after it whizzed past the sun and is on its way out. And it's right now, out beyond Neptune. I think it's heading out again to the cold depths of interstellar space. And we found another one, Borisov, last year, I think. And so there's a few of these. There's probably a lot of these, and we're just getting telescopes good enough to find them. And so that's very exciting, that the space between the stars is full of these sort of flaky icebergs that were born in the outer parts of solar systems and weren't very strongly held to their star by gravity and kind of got knocked out and are voyaging and are just like driftwood in interstellar space. And so what surprised people a bit about Oumuamua is that as it came into the solar system, it wasn't just moving under the sun's gravity. It looked like it was sort of wobbling a bit and moving a bit. But actually, that's really common for comets, which are made of ice. And as they get close to the sun, the ice boils off and acts like a little rocket.
Right.
And so a little pocket of ice in one crater on the comet, right, starts to boil off and it goes that way. And another pocket then breaks through and suddenly you get a jet that pushes it this way. And so we think Oumuamua is probably doing the same thing. It seemed to be doing it a lot, but that is explainable if you think that it's not really a dense like snowball, but it's sort of like snowflakes barely held together in a really like fluffy, like candy floss kind of way. And it's pretty plausible that in the outer parts of the solar system, that's what would happen. A lot of our intuition about what things in space are is sort of set by the inner solar system, right, which we're more familiar with. And as we go on in the outer solar system, the New Horizons probe passed this place called Arecibo, which turned out to be two big ice balls kind of stuck together. Seems like there were two little mini worlds that drifted together and sort of stuck like a double serving ice cream cone, but without the cone. And the cone would have been surprising if we'd found that. And so because the orbital velocities in the outer solar system are actually much slower than the orbital velocities in the inner solar system. And so things are just wandering around and they kind of smoosh into each other instead of smashing into each other and causing disaster, right? And so I think that, that all of the experts in outer solar system stuff that I've talked to about Oumuamua are quite comfortable that it's just this weird, fluffy candy floss iceberg. And however, one of my colleagues here at Harvard, Avi Loeb, really wants it to be an interstellar spaceship. And so he's been publishing papers in which he's arguing that, no, you can't explain it like an iceberg, and that it's almost got to be a spaceship. And, this runs into a number of things. It runs into Carl Sagan's famous saying about extraordinary claims require extraordinary evidence. And it runs into the fact that Avi is a cosmologist by training. He studies the beginning of the universe and the first stars and things like that. The outer solar system is not his expertise historically. He's been trying to come up to speed in it, but everyone who is an expert in the outer solar system thinks he's wrong. So that's not a great sign. And so I tend to believe my outer solar system folks rather than Abby on this one, and especially because, you know, in science, sadly, the more boring answer is usually the right one, right?
Yeah, interesting. Do you guys work alongside each other?
We haven't actually worked directly together. His office is a couple floors below mine pre-pandemic, but we chat, you know, occasionally. And he wrote some papers on stuff that I also wrote papers on 20 years earlier, and things like that. So we have some overlap.
I feel like it's worth mentioning, right, the Billionaire space race, and there was a lot of debate about the Kármán line, and you know, did Branson really go to space? Did Bezos really go to space? What do you think about that?
Well, I'm on record on this one. Yeah, I wrote a paper a couple of years ago in which I argued that 80 kilometers and up is space. And so I put together some scientific arguments for why you might pick 80 kilometers as the boundary for being in space rather than being in the atmosphere. And by that criterion, both Bezos and Branson went to space, even if only for a few minutes. So my argument was, I used the argument that Kármán did. We talk about the Kármán line, and the Kármán line was, you know, nowadays people talk about the Kármán line as being 100 kilometers. But actually, that wasn't what Kármán said. Kármán said, put space where orbital dynamics becomes more important than aerodynamics. And when you actually do the math and crunch the numbers, I showed that that comes out to about 80 kilometers. And then if you actually then ask a different question, which is, well, if you look at satellite orbits, how low can satellite orbits get without the satellite burning up? And that also turns out to be 80 kilometers. And so putting those two things together, I concluded that, yeah, 80 is a better number than 100 in this particular case. And so now these flights were only suborbital. They weren't orbital. And so there are some people who get confused by this and go, well, it's not space if it's not orbital. I mean, that's just nonsense, I'm afraid. You know, because you could go all the way to the moon without going orbital. If you know, wouldn't be fuel efficient, but you could do it. So I think there's no question in my mind that they were both in space. And now the different question is, should you call them astronauts? In other words, is the word astronaut synonymous with space traveler, or does it mean professional space crew, right? And that's, you know, that's, the language is evolving, and I don't think it's settled yet. My bet is that we'll have another word for professional space crew, and I'm advocating spacer, which is what, you know, Heinlein used in the 1950s science fiction novels. But that astronaut will end up including the tourists. And the reason I think that's the case is because the tourists have a vested interest in that being the case. And the tourists are all incredibly rich and powerful people, and therefore they're influential.
Just a little bit. I like that, spacer. Sean Collins says, Jonathan, what's the craziest thing you've seen in space?
The craziest thing I've seen in space. Ooh, you know, there's so many candidates.
Yeah, I bet.
And you know, there's things I've seen personally, and there's things that I've, you know, seen my colleagues find. I would say the craziest thing I've personally studied is a galaxy called ARP 220. ARP 220 is actually, it used to be two spiral galaxies like the Milky Way that about 10 million years ago did a head-on collision at a, you know, at hundreds of thousands of miles an hour, smashed into one another. The gravity of the cores of the galaxies felt each other and squished down into one big blob. The spiral arms of the galaxies kept on going, and smashed into one another, and a shock wave went through that heated the gas to 100 million degrees. And now those rings of shocked gas are finally feeling the gravity of the central crash and are falling back towards it. And stars are forming in that gas as it does that. And in the middle of the whole thing is a pair of supermassive black holes, each tens of billions of times the mass of our sun, that are orbiting each other and eventually will spiral around each other and merge in a huge gravitational wave burst. And in the meantime, they're putting out scads of X-rays. And so there's just so much. I mean, it's basically a huge train wreck in space, and there's so much going on in this system. It's such a mess, and it's just spectacular.
So that one really intrigues you.
So that one I had a lot of fun studying. Yeah. Yeah.
What is your favorite celestial body? Luigi Daniel wants to know.
My favorite celestial body. Well, clearly it is minor planet 4589 McDowell, because it's named after me, which is a little rock about a mile across orbiting the sun between Mars and Jupiter. But also, you know, I'm also a big fan of the quasar PG 1407 plus 265, which is about 6 billion light years away. And just because it's a quasar I've studied on and off for 25 years, I just published a new paper on it that's just out on the archive, and it's about 10 billion times the mass of our sun. And so if you think of our sun, right, our sun is shining, has been shining for 10 billion years. And over that 10 billion years, it uses everyone's favorite equation, E equals mc squared, to turn mass into energy. And it takes 0.1% of its mass and turns, little by little, turns it into energy over 10 billion years. And that's all the energy that ever comes out from the sun, of which a tiny part of that, right, is all the energy we ever get here on Earth.
Right.
All right, so that's 0.1% of a star over 10 billion years. PG 1407 plus 265 takes 100% of the mass of the sun and turns it into energy every year.
Wow.
Right? Just insanely more luminous, insanely much more. You do not want to live next to this thing.
No.
So that's another favorite. And then, you know, the other thing, of course, is stuff you look at through a telescope, in an amateur telescope, right? And my favorite things to look at are Jupiter and Saturn. Saturn because of the rings, of course, it's so beautiful. And Jupiter because you can actually, if it spins so fast, you can see the cloud formations moving if you watch for a couple hours.
Wow. That's crazy. I would like to see that. Let's see. Grow Veg UK question: do you think there's any truth in Bob Lazar's claims from the 80s?
From whose claims?
Bob Lazar.
Oh, no, I can't remember what those claims are, but I remember that they were nonsense.
Okay. Okay. Like Area 51 and the secrets, you know.
Oh, that?
Investigations going on, yeah.
I mean, there's always secret things going on at Area 51, but it's not aliens. It's like
reverse engineering, like alien spacecraft.
No, they reverse engineer Soviet fighter planes. That's what they do there.
Okay.
And the reason they were so sensitive, right, is that they had bought Soviet-made fighter planes from third world countries and had got them, and they didn't want the Russians to know that we actually had their fighter planes that we were testing and doing Top Gun tests against, you know, to learn how to defeat them. So that was one thing. And then the stealth fighters were also being tested there. So basically all of the really super secret stuff, but just conventional, you know, nothing alien. Again, here's the thing, right? the government sucks at keeping secrets. Even the secret parts of the government suck at keeping secrets. And I've been studying, you know, our spy satellites, which are some of the most secret pieces of what the government does. And the amount you can figure out even about those is huge. And the amount that kind of leaks out despite being super secret is ridiculous. And so, you know, that was even before WikiLeaks, right? And you know, if there were aliens at Area 51, that would have come out in WikiLeaks, I'm for sure. But yeah, no, absolutely not. There's the government is just not competent to keep a secret of that magnitude. That's the bottom line. And there's just no reason to think it. You know, it's just you know, it's fairly well understood what's going on there. There's no evidence, right, that alien technology is making its way into our weapon systems, right? You know, I think it'd be pretty obvious if that kind of thing was happening, and it's just not.
A lot of people, though, are really into it, right?
Well, yeah, I'm sorry. You know, a lot of people, I'm sorry, in this country believe things that are manifestly not true. And from things about vaccines to things about aliens, and I just got to tell it like I see it. And from my knowledge, which includes, you know, I don't have a security clearance, but I've looked pretty deeply into a lot of secret government activities, and I've looked very deeply into, you know, things in space, and you know, UFOs and things like that. There's no doubt in my mind that there is no evidence for advanced aliens visiting the Earth.
I think we have a couple minutes left. Justin Hernandez asks, John, would you go to space?
Hell yes. I actually applied back in the 90s. I applied to the NASA astronaut program. I didn't get accepted. I'm not enough of a jock, you know. So I have two things against me, right? Is that I'm not like a sporty jock who parachutes and and scuba dives and things like that. And I'm not good with money, so I'm not a billionaire. And so those are the two main routes, right, that you want to be to go there. So yeah, so sadly, I can't put myself on my own list of astronauts. It's not going to happen at this point. But you know what? I've had, you know, I wanted to be an astronaut when I was a kid, and that drove some of what I did, and I don't regret it because it got me, you know, into the space program. It got me involved in working on a spaceship that we launched into orbit around the Earth to study black holes from space, right? I was in the control center when we, you know, were taking the first pictures. I was at the launch pad when we saw the shuttle take it up. Well, not at the launch pad, a couple miles from the launch pad.
Yeah,
that would have been bad. And you know, and I got to know a bunch of the astronauts, and so I've been enough immersed in the space program that I feel like I've achieved enough of my dream, and I've had a really interesting and exciting time doing it.
so much is going on right now in space in 2021. What are you most excited about?
Oof. Well, yeah, I mean, it's, you know, it's a really exciting time. We are, let me see how to order them. I mean, obviously the work with Starship is fascinating. I think I think Starship is a little further off from being good to go than a lot of SpaceX fans think, but it will get there. And so I want to see that happen. I think, you know, the SLS, I have grave reservations about the big NASA rocket that's going to take astronauts to the moon, but maybe we'll see its first test flight this year, and, you know, better late than never, and that'll be good. It'll be an impressive rocket. We have, the Ingenuity helicopter on Mars, right, has been just a fabulous little small, relatively cheap tech experiment that's just beautiful, I think. We have the James Webb Space Telescope that's slowly marching towards launch. We have what do we have in the other? So, I mean, there are various sort of plans in the works for more missions to the outer solar system, which I'm really looking forward to. There are there's all kinds of little scientific satellites that are beavering away, making fun discoveries. So it's, and then we have the advent of the space tourists finally, and so including things like the Inspiration 4 mission with the Free Flying Dragon. I think, if they can bring the cost of orbital space tourism down, then they'll really have a market. So I think that's very interesting.
Awesome. Let's see. I think we're just about out of time. I wanted to keep this to an hour because I know you're a busy guy.
That's okay.
Let's see. What's it going to take to mine asteroids? Will we do it? Can you answer that quickly?
Eventually. So there've been a couple of asteroid mining companies that have gone bust now. It's a little early, but we also have, we've, in the past year, Japan brought back a sample from asteroid Ryugu and landed it in Australia. And the American spacecraft OSIRIS-REx picked up a sample from asteroid Bennu, and it's on its way back to Earth with it now. And so that's, technically asteroid mining, even though it's like a little handful of stuff that they've got, right? Yeah. But again, it's proof of concept, right? And so I think we've got a lot of prospecting to do still. Very exciting, the Lucy mission, which is an asteroid prospecting or surveying mission, just, I think, got taken to the launch site. It's going to be launched later this year. There are a number of missions that are going to, the Psyche, which I think is going to look at a all metal asteroid for the first time. And so I think we're on track, not soon, but eventually, to start mining the asteroids. And it's one of the things I would say, bigger picture, right, is that we're seeing low Earth orbit really become home territory, right? In other words, we don't need NASA to take you to the space station anymore. We can make the trucking company SpaceX do that, right? Right. And it's normalizing activities in low Earth orbit. We're starting to see something of the same thing in the whole inner solar system. That the inner solar system used to be NASA and the Soviets. And now we're seeing probes to Mars and probes to the asteroids by, China, Japan, India, right? And even, to the moon with private companies like the Bereshit Israeli probe, and of course SpaceX wants to be in that sector too. And so the frontier is moving out to the asteroid belt and the outer planets, and the inner solar system is becoming humanity's home territory. And I think that's a really exciting development, and asteroid mining is going to be part of that.
Awesome. Well, hey, it's been an hour. We've covered a lot. We've gone back and forth, and I feel like I've learned a lot. I think that my viewers have learned a lot. I really thank you for your time in chatting with us. Is there anything else you'd like to say?
This is always fun to chat with you, Eliana, and I'm happy to do this again sometime if you want a wide range. It's fun we can talk a little bit more about black holes. We can talk a bit more. There's whole spiels I can do about space junk that we didn't get into. So yeah, there's a lot to cover, and it's always fun to see what people are interested in. And I just want to look at, let's see, why is it taking so long to build a moon base? Well, that's coming now. Wait 10 years. What's my favorite rocket? Ooh, I actually think my favorite rocket was the 1960s era French Diamant. just because, you know, the French do style, right? And it just looks pretty. So that's the one that comes to mind. Can you still see the Tesla car in space? It's too far away for us to observe it, but we know it's in orbit. We know where it is. And it's still bolted to the Falcon 9 second stage. It's not floating around on its own. And it's orbiting between the Earth, orbit of Earth and the orbit of Mars, just going around the sun again and again and again.
That is so cool. Wow. Well, okay, so that means there will be a next time. We'll have another live stream.
Till next time, Elliot.
Yes, until next time. Awesome. Well, thank you guys for tuning in. We really appreciate it. And yeah, more to come, more to come. So enjoy your Friday. I think I just end this, right?
I guess you do.
Awesome. Thank you so